Yeah, so this is working and I can see my mic, so that's fine. So today should be pretty quick. What we're going to look at is attempting to... I was trying to get Cucumber to act as our test framework, and using the WebDriver technology that Ian's team have decided to use, which is WebDriver.io. It's just a JavaScript API wrapper around Selenium effectively, but it's quite nice. Dean's got some working examples of WebDriver.io. I failed to get the most basic case working. Something to do with my pathing's not correct, so we're going to abandon that and actually just forget about Cucumber and just use WebDriver. And we'll, instead of running a test, we'll just print out to console what we've managed to get hold of. So the point I'm at now is I have a basic WebDriver script that will open Google and print the Google title. It just says, I think it says welcome to Google or something like that. The important part is that we'll see how we open a browser, how we get elements, and then we can just check that elements match things and print true or false at the bottom, basically, is what we'll do today. And then between now and next week, I'll get Cucumber working. We'll actually start building a little Cucumber framework around this. And then we can add more front-end pages, more back-end functionality, and we can build the back-end tests in Python, the front-end tests in Cucumber.js, and we'll go from there. So nothing's changed here, and I'm just to recap, I'm going to explain what we've got on the back-end. So I've got a really simple Flask application in Python. I've got an index which returns a rendered template in index.html.
With a cool font.
Oh yeah, with a cool font, we'll get to that. And I've got a /greeting, which is just a JSON endpoint that returns hello world, basically. So I can run this, and now I've got this is a terminal. I've just split it into 3 panes. There's nothing special here. So I can run this in the same way we always have done. And then I can open Chrome. Let's get a new tab and bring it over here. And I can go to localhost 5000, and here's our really cool hacker website. Sorry, right. I can also see /greeting, and there's the JSON that we were seeing before. And I can see my 2 HTTP requests in my debug log here. Now, let's ignore the application. We'll leave the application running, but let's ignore it for now, and let's move on to WebDriver. I've created this file, and this is nothing to do with our application, but this is simply a script that will open Firefox, go to google.com, and then log out what the title of the web page was. And the way it does it is you use this get title method. Title, and this is the most basic way you can use WebDriver.io. But before we get to it, let's explain how we can use this, because we can't use this file straight away. So some prerequisites that might be pretty obvious to you both, considering we've probably worked with JavaScript before, and I know you've seen some of it.
Yeah, seen some of it.
So with Python, you'll probably remember that we had a requirements.txt. So let's have a quick look in there, requirements.txt. And I've got 2 items in my requirements text, and that's Flask and requests. Now these are just libraries that don't exist in the core Python libraries, and I download them from a repository which is called pip, and I use pip to install those locally. Then I can use them in my project locally. Nearly every programming language has something similar. They're normally called package managers or dependency managers. JavaScript or Node uses NPM, Node Package Manager. To turn any project into an NPM project or a Node project, you just create a file called package.json, which is very similar to my requirements.txt, but it's a bit more verbose and it's got some more information in there. And I've created a very basic one. So package.json. You've got some sort of metadata about your project. You've got automation training, and let's get rid of some of this because it's not needed because I haven't got this working. This is all extra stuff. Let's keep this as limited as possible. So I've got this package JSON file, and it is just JSON, and so you need a name. A main I don't think you need, but normally it's specified as blank if there's no obvious entry point to the application. An author, I've just put my name. A license, so we're just going to put the open source MIT license. And then your dependencies. So this is sort of, this part here is what we see in requirements.txt. Here we're just going to ask for WebDriver IO. And we want any version greater than, that's what this little hat's for, 4.8.0. So if 4.8.1 comes out tomorrow, when we rerun npm install, we'll get the latest version.
Do you have to put in the name, main, author, etc., or is they just convention really goes in?
I think it's just, it depends on the version of Node and npm that you're using. Older versions of Node, it will just do whatever you want. I think newer versions are a little bit more strict about the structure of your package JSON file. Don't ask me about the specifics. Basically, take them out and try, and if it fails, it's got some pretty good messages. It will say, I was expecting such and such key value. So let's save this. Now, just a quick bit of tidy up from what I was doing before.
That is our lowest supported version.
I'm just going to delete this file locally. Now I have on my machine Node and npm installed locally, so you'll need those as dependencies. You could just Google how to install Node and npm. I have 5.3, and when I run npm install, that's going to look for a package.json and get the dependencies. And it will install them, much like the virtual environment for Python, it will install them locally in your local Node modules directory. So what it's doing now is it's analysing the dependencies that WebDriver IO requires and gets all of those, and recursively goes down each of the dependencies like a tree, and it will install them all. So it's installed 154 packages when I only specified one. So it just sort of cascades down this tree and gets all the different packages that it needs. And if we have a look in Node modules, I'll have all of the different packages installed there. But what that means is I can now use them in my local JavaScript project. So I have this JavaScript file. I require, and this is how we get our dependencies. In Python, it's import. In JavaScript, it's require. And we assign it to a variable. So let's talk through what we're doing each line here and compare it to, let's pick a good comparison file. Let's compare this to, let's compare these two. So this is our Python file. So we've got our two dependencies that we need to run this script. At the top, the equivalent in JavaScript is this require line. And let's split this out. So in Python, we just import. In JavaScript, we have to set that import to a variable name. We have to tell it import this as this. Interestingly, you can do the same in Python. You can say import requests as R or something like that, and then use it as R later on. Some people do that. And then we're straight away into setting variables and doing things with them. So we create this options variable, which is just it's a JavaScript object. It has a key of desired capabilities, which the value of is another JavaScript object, which has a key browser name and a value Firefox. The reason we do this is a structure that we can pump into our WebDriver object that it will pick up and see, oh, I need to set my browser to Firefox, and then I'll look for my Firefox driver, which on Mac is called Gecko, and it's actually just like a binary. It's like a .exe or something from Windows. It'll pick up that binary, and then it will attempt to connect with that binary to a Selenium server so that it can talk through to the browser and back again. Here is where we so what we're doing is, this looks nicely formatted, but you can just pump this all onto a single line, like this. We're just chaining these methods. Oops. I can, and I was keen to try this, split this out. So this is what we have at the moment. Now, I'm going to comment this out, and we're going to try this in a slightly different way. So I'm going to create a browser equals new WebDriver IO browser options remote. I can then pass in my options. Browser.init, start the browser up. Browser.url. Google, and we'll leave it there, won't do anything, I just want to see it work. So this is a little bit more verbose and a little bit obvious what's going on. I create this browser object. I presume I actually, this is where my understanding of JavaScript goes out the window. I might actually need that. No, we'll see, I might. But we can run this. I'm going to run it in this window, and I run it with my JavaScript interpreter, which is Node, and I expect this to fail. Test.js. WebDriver is not a constructor. Okay, so maybe I don't need to instantiate it because I've required it.
It looks very similar to the water controls. It looks very, very similar to that, and then you don't have to instantiate it. You just say, I want this browser, and then from then on you just say browser dot.
Let's revert back to what I know works, rather than trying to be clever.
Control Z.
Yeah. Right. Now, I still expect this to fail, but for a different reason. Yes, nothing happened. Now, it's silently failing, which isn't good, but that's just because there are no debug options set on that instance. So the reason it's failing is that the WebDriver, the driver object it's got, the driver binary, the Firefox binary, is starting fine, but it's not connecting to Selenium. So it has no idea how to connect through to an actual Firefox running instance, and that's because I don't have a Selenium server running on my machine. So I can start a Selenium server using a jar. Basically, you start it with Java. It's a Java application, and I've already downloaded it. It's here. It's this Selenium server standalone. Just Google how to get this running, and it's I've got the command here, Java -jar. You supply which driver you're going to use with it, and I've supplied Gecko driver, and then you start the Selenium standalone server. So now it's running, and you can see it runs just like our web server. It runs on localhost, but on a different port. So this is running on 4444, whereas our web server was running on 5000. So now if I run that test again, and I will minimize this window and close this one, and make this a little bit bigger so we can see. Hopefully we'll see Firefox open. So there's Firefox just opened up here, and in the background it's gone to Google, closed, and said title was Google. So that's that's pretty cool. We're already at the point where we've got something opening a browser, inspecting elements, and giving us back what we want. So instead of doing that, let's actually get what we've built, basically. So we're going to change this URL to localhost 5000, and then I don't want to get the title. I want to I'll comment this entire bit out. I want to now use a slightly different method inside this WebDriver IO. So let's not forget what we've got. Yeah, Chrome's over there. So if I come here, this is the page that we're going to test, and I want to check that this text is correct. So if I inspect, I can see I've got a... can I make this bigger? Yes, I can. Look at this. So I can see my HTML page is pretty simple. I've got a head that's empty. I've got a body that has a background color, and I have this paragraph text. And it has an ID of message space, interestingly. Let's fix that. Template, index. Let's reload and check that's fixed. Yeah, ID of message. And then I've got the text inside there. Now, if we look at the WebDriver IO selectors, this is how we get at attributes inside the web page. There's lots in here, but the one I'm looking for is getText. Browser.getText. That's what we're going to use to get that text inside of that element. So I'm going to, instead of getTitle, I'm going to getText, and then and then I need to pass an element name. Now, because I have an ID, I can use the hash key selector. I can say the ID name, and then I'm going to use this same format that they've got above. Now I'll explain what this does. So you get the title. So at this point you've got the title and you want to do something with it. This is where JavaScript's asynchronous programming comes in, and it's not completely obvious if you've only used synchronous programming before. So you're using this .then method. Now .then is a promise. So what that means is I'm going to take something I've got and tell you what to do with it in the future, and I'm going to supply basically a callback function that says take this thing and then attempt to do something with it, and here's what to do if it's correct or if it's wrong or if it's a failure. It's often used for things like in browsers, you know, attempt to set some attribute. If it fails, revert back to this. If it passes, do this. It's just a nice method of doing this sort of cascade programming. So I'm going to stick with the same format. .then, and then you supply a function which takes a parameter that we're going to call text, and you open a function in exactly the same way as always, and then we're going to do the same thing. Console.log the text on the page is plus text. So we're doing the same thing. I'm basically creating this little print message, and I'm going to pass in the text that we got back from the browser. That's all we're going to do. And then we'll .end will close the browser. So let's save this and see if I've done this right. I can't guarantee I have. Where's my terminal gone? Let's run this. So we should at least see Firefox open still. Yeah. Cool. So that worked. So it says the text on this page, welcome to automation stuff on this web service. So we've now got a method of collecting information out of the page, and we can do stuff with it. So instead of logging it, what we're going to do is we're going to try and make sure that it was equal to what we expected it was. So this is by no means a test framework, but this is just a really shoddy way of running something that will tell us yes, it's okay, or no, it's failed. So let's set a variable expected text. And now, because we're working backwards and we shouldn't be, I can just copy my expected text to here. And now we need a way of saying does the text we got back expect the text? Does the text we got back match the expected text we set in the beginning of our script here? And I'm going to change this text to element text. So I'm still going to do a print console.log, and I'm going to say what are we going to put? Let's not actually print any text here. Let's just print the outcome. So I'm going to say element text. And now this is where we get into funky JavaScript equivalence checkers. So in most programming languages, and I'll just do this in pseudocode quickly, you can say A equals B will set, let's do this the other way around, A equals 1, 2, 3 will set A equal to 1, 2, 3. If I do A equal 1, 2, 3, that will return true. That will return true because you're saying does A equal 1, 2, 3. In JavaScript, this will also work. It's duck typing. It's saying does it roughly look like a duck? If it looks like a duck, then it probably is a duck. So this will also be true. Now, A equal 1, 2, 3 in JavaScript is false, because you're checking not just that you're checking the actual object type as well as where it's come from. If the object is even slightly different, it will fail. So that is true. So because this is a string, but it looks like the original, it's false. But with the double equals, the roughly equal to, it's true. So whenever you're using tests, it's always best practice to use triple equals, because you're checking the actual equivalence of the objects, not just the references. Okay. There's a much better explanation for this. It's to do with reference versus pointers, and you'd have to Google it. I'm not that great with it.
As a safe bet, always triple, and then it covers everything you want.
Yeah. So I've said we're going to log the output of this little expression. So let's save that and see what we get now when we run it. True. Yes. So let's just check that this works. It's always good if you write a test after the functionality has been implemented to change the functionality and break that test and show that you're actually checking for the right thing. So what I'm going to do is change the text that we get back and see my test fail. So welcome to the automated stuff web services. Fucker. And Google will probably mark, YouTube will mark me as an adult web channel now or something. So if I rerun this, false, which is really good. Let's change that back. I've changed it back, rerun my test, it's good practice, it doesn't take very long to run. And we're back to true. So now we have tests in Python and tests in JavaScript. Now the difference is the test in Python doesn't actually start a browser, doesn't check that you're loading the web page, doesn't actually pull the elements out. It merely just asks for information back from an endpoint and checks the content. So this is, for our little application here, there's probably a good example of a split between unit tests and integration tests. These are the unit tests, and they can run anywhere. They don't even need to start the application because they'll start them themselves. And then we've also got the integration tests that expect your application to be deployed somewhere for it to run against because it's got to talk to an actual web address. So even though they're in two vastly different languages and they're in two different frameworks, that's okay because they're two different types of tests and they do different things. I think for next time we will wrap this in Cucumber and we'll get this working properly so that we can have a feature that says my index feature as a user of the Automation Stuff web service, when I go to the home page, I expect the welcome text to be whatever, and we'll split it into step definitions, and we'll actually have a working little application that we can then, we've got all the foundations we need to build more and more features on. But I don't think we're going to do much more today because I have failed to get anything else ready. I did work on, while we're here, I can show you. I have an example of what a feature might be for us. As an internet user, I went to visit the home page, and then I have this steps.js. Let me uncomment all of this rubbish. And this is how we define our step definitions. So it's horrible regex, which is disgusting, but this is a lot of how Cucumber works. Yeah. When I open the URL, browser URL, basically go to this URL based on some config we've got set. And finally expect and this is, you can see this is very similar, get text, element name to equal matches. So it's very similar to what we just did. This doesn't work yet though because I haven't got the dependency set up properly yet on my machine. But I'll do that for next time and we'll be ready to go then. So I think that's all we're going to do today. I will commit and push what I've got, and you guys can put it down and break it and play with it. And now that you've actually got a little object that you can see in the browser, you can do different things and drive different places and try different things. See what APIs are available on the WebDriver IO Selenium wrapper. So that's it. Cool. Thank you.